So now we're going to find the loose structure for ozone or O3, which is one of the pollutant gases that we'll talk about. And in order to find the loose structure of O3, we first have to understand find out the total number of electrons in O3. So whenever we want to find the total number, we should always go back to the periodic table and find out the total number of electrons needed to complete the octet. So for every element except hydrogen, beryllium and boron, everyone needs 8. So in this case, oxygen as well needs 8. But since it's O3, so we multiply it by 3. And here we get 24. Then we go to the valence and we see how many electrons it actually has in its natural form. And oxygen has 6 electrons, as needs 2 to complete the octet. But we also multiply it by 3 again because it's O3 here. So 6 times 3 equals 18. And then we find the shared electrons and the unshared electrons. For the shared electrons, it's 24, the total minus the valence. So 24 subtracted by 18 equals 6 shared electrons. And to find the unshared, it's 18 minus 6. So 18 minus 6, which equals 12. So now we're going to use the information we have here. Let's circle it. So now we're going to use the information that we have and draw the loose structure for O3. So in the beginning we have 3 oxygen molecules, O. And now the first thing we do is try to find the shared electrons. And the shared electrons are represented by a line, and each line consists of 2 electrons. So we're going to have 2, 4 and 6, and that completes the shared electrons. And now we go to the unshared, and we go to each oxygen to find how much it needs. So for this oxygen molecule, it has 2, 4, meaning that it needs 4 more electrons to complete its octet rule. So we're going to have it like this. And then for this oxygen, it has 2, 4 and 6, so it needs 2 more electrons, and that's it. And for the last one, it only has 2, so it needs 6 more electrons. So 2, 4, 6, and that's the loose structure for O3.
Okay, we're going to form the loose structure of carbon monoxide. Our first step is to find the total amount of electrons found in carbon monoxide. So for total, since all elements except barium and hydrogen have 8, so we are going to use 8. And because we have 2 elements and 1 atom of each, we are going to multiply it by 2. So 8 times 2 equals 16. Our next step is to see the valence. So to find out the valence, first of all, since carbon is in group 4, we'll have 4 plus oxygen, which is from group 6, which will be equal to 10. And now to see how much shared electrons we have, we are going to subtract 10 from 16. Use the total amount of electrons and subtract it from the valence, which will be equal to 6. And then the unshared will be the valence minus the shared, which will equal to 4. So now our next step is actually illustrating the loose structure. So what we're going to do is we're going to have a carbon atom and an oxygen atom. And since it says here that we have 6 shared electrons, what we're going to do is form 3 lines, each line representing 2 shared electrons. And then to complete the octet rule of both carbon and oxygen, we are going to add 2 electrons to each side. So in this way, both atoms are satisfied and have full octets.